Welcome to the Nelson Mandela University Reserve. We're going to be your hosts on this field trip today. I'm Alistair Potts.
I am Adrian Groble.
And we're really excited to show you everything that our amazing reserve has to offer.
Today we find ourselves in a dune landscape. As you can see, it's not your typical dune landscape where you see masses of sand flying around. We are in the eastern end of the Cape Floristic region, where the true fynbos starts to peter out, giving way to typical summer rainfall vegetation types like grassland and savanna. So in these dune landscapes, like we are in today, we find a very special type of vegetation, which is actually a mosaic of two vegetation types, namely fynbos, as we see around us here, and fire-adapted type of thicket, which we have in the background. While these are fire-driven landscapes, we also find small little pockets, especially where the dune topography makes hollows in the landscape, or small valleys, where fire is unable to penetrate. So in these landscapes, we also do find certain types of thicket that are actually fire-avoiding, and that are where the species are sensitive to fire. And in some cases, these pockets can also develop into coastal forest. What we'll be doing today is we'll be walking around through the veld and exploring some of the species that are typical of the vegetation types, as well as some of their ecological features of the fynbos, the fire-adapted thickets, and the forests. We are in a patch of dune fynbos at the moment, and a feature of this veld type is it's made up of two groups of species. The one group is species that are found only in dunes. So they are endemic to dunes and do not occur off that type of soil anywhere else in the Cape. So one example that we have here is Fhallica echinata, the Dune Daisy, or in Afrikaans blauwblommetjie. And the other group of plants that we find are species that are very widespread throughout the Cape. So they occur on the dunes as well as off the dunes on other types of soils, for example acid sands, or sometimes even in clay soils where you find renosterveld. So this is an example of one of those species. This is Passerina corymbosa, common gonna. In our dune fynbos, it's called dune fynbos because we get the typical Cape lineages that you find in any type of fynbos. So one example that is very common in dunes throughout the Cape is this blombos, Metalasia muricata. Another one is of the buchu family, the Rutaceae. This one is Coleonema pulchellum. And one of the very, very typical families of the Cape fynbos, the Ericaceae. So here we have an example of Erica, which is really the only genus of Ericaceae that we do get in the fynbos, and it's the same in the dune fynbos. So this is Erica glumiflora, which is a dune endemic. So this doesn't grow off dunes anywhere else, and it only grows in the southeastern Cape Floristic region. Another example, this is Phallica, also very typical of fynbos. This is Phallica ericoides, a dune endemic species. In our dune fynbos, we have most of the typical Cape families, but perhaps the most conspicuous absence in these landscapes is the Proteaceae. So anywhere in dune fynbos, be it on the west coast, the south coast, or on the southeast coast of the Cape Floristic region, you won't find any examples of Protea, Leucospermum, Leucodendron, or any of the other more western genera of the Proteaceae.
There are some dunes in the Cape that do have Proteaceae on them, but they're very different from these dunes. These are generally Holocene and Pleistocene, so they're tens of thousands to hundreds of thousands of years old. But if you're walking along and you're walking on a dune system and you come across members of the Proteaceae, that's because you're on a dune system that was millions of years old. So what's happened is that all the calcium is leached out. It's not alkaline, it's shifted onto a more acid substrate, and that's allowed the proteas to move in. So just keep that in mind when that in the Cape we have these very recent sands, and we have some of the few ancient dune systems globally. We have some of the few ancient systems that are acidic.
When we think of dunes, we don't really think about fire, but coastal dunes in the Cape, where we have dune fynbos, are absolutely fire-driven systems. So in the early post-fire environment, our resprouters tend to be the dominant component. But as we can see here, when fire has been excluded for some time and fynbos has been allowed to mature, the reseeders really start to dominate. So for example, here we have Collionema pulchellum, and one of our ubiquitous dune species, Metalasia muricata, in the background. And some other examples also include Anthospermum ethiopicum and Phallica ericoides. What we see here is that the road has acted as a fire break. So on my right hand side is where the mature fynbos is, where the reseeders are dominant, and in stark contrast to that is the young fynbos, which burnt only a few years ago. So in our dunes we have really three graminoids that are dominant pretty much throughout the reserve. The one group that we have are the restios, which are typical of fynbos throughout the Cape. But what is different from the reserve here and other areas of fynbos is that the restio flora is very, very depauperate. So we only have two species. One is Elysia microcarpa, the other is Restio eleocharis. And both of these are dune endemics. They also sometimes occur in limestone fynbos, but mostly they are restricted to dunes. The other graminoid that is quite dominant in our dune landscapes around here is this grass. This is Imperata cylindrica, and the distribution of these different graminoids is largely controlled by microtopography. So the restios really occur in slightly drier areas, higher up on the dunes, and the grass Imperata cylindrica becomes the dominant component in slightly lower bottomlands, in valley bottoms, and especially in seasonal wetlands. Behind me you can see a small little depression in the landscape, and what is immediately obvious is that Imperata cylindrica becomes the dominant graminoid, even the dominant species. It's actually has become a small little grassland in this tiny little seasonal wetland.
So what's interesting about the parts of these dune landscapes that have got fynbos on them is that there are thicket lineages that have broken in. And so here's an example of, and it's Rapenia Giliana. Now this species never grows very tall. So it's only grows to about 1 meter in height as a maximum. And so here's another rammet, and there's another one over here. But what's very interesting is that we've dug these up, and what you usually find is that they're connected underground, and it's an extensive underground root system that just carries on growing. And so so the trees are playing a different game in the dune systems. They're growing underground and spreading via what are called soboles. Rapenia Giliana is not the only species that can play this game. We've also got Cerca levigata, which also never grows exceptionally tall, and also spreads underground. And I'm sure we can find another one somewhere here. Here's Euclidea Rasamosa. Now, Euclidea Rasamosa is very interesting because it can grow as a tall tree. It can grow, up to about 3-4 meters. but it can play this underground sobol resprouting game and kind of the sunken tree game. So on these dune landscapes, as soon as there's a little bit of topography and the kind of medium to shorter dunes and there's an accumulation of sand, we start to find that the thicket elements start to dominate and we start to get these clumps of thicket. So here I'm standing in a Euclidea Rasamosa clump, and this is likely all one individual that I'm standing in here. And the interesting thing is, now, did the dune first develop and then this plant grew and has now effectively stabilized this dune? Or did the plant start growing and then the dune has accumulated around it? So how much of the dune dynamics in these kind of back systems where there's not a lot of sand movement is driven by the plants, and how much is it driven by the wind? So these individuals become really, really dense, but not so tall as to exclude the odd kind of fynbos element. Here we have a helichrysum, and it's still managing to get enough light within this patch to continue to grow, and we can actually see that there are restio Iliocharis, that are still managing to hang in on this on these dune patches. And here, if we look, we've actually swapped from a Euclidea into a Circia levigata, and so here is likely to be another individual, but this time of Circia. And it's actually quite noticeable when I turn around and look backwards, where one individual ends and another individual of these underground sobol resprouters begins. I've been talking about this concept of underground trees, and Euclidea Rasamosa is one of those that can certainly grow as a sobol, which is branching sideways under the ground. What exactly does that look like? Well, it's really tough to investigate that in a stand of vegetation that's a couple of years after the fire, because the root network is very intact. But just after a fire is the perfect time to be able to start to see how that root network has developed and how ramets are connected to each other. And so this patch of vegetation that we're in now burnt about 9 months ago, and so there's still an opportunity to be able to get in and have a look what's going on at the root network level. So I'm going to dig up this Euclidea, I'm going to dig up part of this Euclidea Rasamosa. So you can immediately see that this isn't a seedling. There's the previous ramet that came up from this section. So let's carry on looking as to how these might be connected. You can see the previously burnt out stumps. Oh, sorry, I just broke it off there. So these two aren't even connected yet. It's just overgrowing each other. So, what look to be different individual plants are growing along these sow balls, and you can see where old stumps were, and they're connected, and they're all heading into this main clump. So we've got this really thick underground branching structure. There's a slightly thinner one, and there's probably another one connecting out here. So that brings us to the question, how big are these individuals? I'm just going to quickly walk around what I think is going to be the edge of this Cercia levigata individual, just to give you an idea of how big it is. So let's change our perspective for a moment, and let's have a look at how big these underground trees could be from the air. This is likely to be one individual. These individuals may spread more than 30 meters underground. It's much easier to identify possible individuals after the fire. There are parts of these dune landscapes that don't experience high fire frequencies. In fact, where fire is almost entirely absent. And where that happens, then you get thicket patches developing. And we also start to get new thicket species that aren't very tolerant to fire. For example, the milkwood, Sideroxylon inerme, is a weak resprouter to fire, but if there are frequent fires, then that species gets removed out of the landscape. So this is why we call it the dune fynbos thicket mosaic, because there are areas in the landscape that are fire prone because of the topography, the prevailing winds, and those areas will normally house a combination of fynbos and those subtropical thicket lineages that are very resistant to fire and that are playing more of a fire game. And then we get these thicket patches that occur in the fire-refugia that don't burn all that regularly. And these thicket patches, with that extended period in between fire and with additional moisture availability, can also turn into forests on the exact same substrate and the exact same macro environment. So here we found Rapenia Giliana in fruit. And you can really start to pick it out in the landscape with these black fruits. So there's an individual, here's some individuals, and here's some more up here. And what's really fascinating and a bit of a conundrum for us is that it fruits like crazy. It really produces a lot of fruit, and they're really tasty and delicious. What you can normally do if you're walking in the reserve is grab a branch and walk along and munch them. And a little bit like grapes, a bit dry. But what the conundrum is that they're these really delicious fruit, and it produces kind of an abundance of food, and yet we can't find anything that eats it. So obviously the dispersal agent for this species is now absent in this landscape. What could those dispersal agents have been? It's unlikely to have been frugivorous birds, because they like to have a closed canopy to be able to move around and kind of be protected. This landscape's a little bit too open for them. But maybe it could have been chacma baboons. An idea that I rather like is that maybe it was early humans that were the primary dispersers of the species. So similar way that I might grab some of these and munch them moving through the veld, maybe early humans would also do the same and disperse the seeds as they move along. Anyway, that's completely conjecture, but it still remains that this species seems to be lacking a dispersal agent in this landscape, and what happens is that the fruits just shrivel up and dry and the seeds just fall to the ground.
Not all dunes are made by wind and sand, as we discovered here. Some of them might actually be made by humans. This one, at its core, comprises a shell midden. This area burnt not even a year ago, and previously it was covered by a small patch of dune thicket. And as we discovered when the fire came through, this is actually an ancient human trash heap. We know of middens in the area, but most of them are very close to the shore around Cape Recife. And this is one of the ones that we've found furthest inland. At the moment we're standing approximately 1 kilometer from the shore, and these middens indicate areas where people discarded old shellfish that they harvested in the area. And what's also nice about this midden is that we've found some very rudimentary stone tools dating from the Middle Stone Age. These are rounded mashing tools, but what is very interesting is that we don't find these types of rocks in this specific landscape, these very rounded sort of riverine rolled pebbles. So these have definitely been brought in by people who lived in these landscapes and transported to this site. Similar to other parts of the fynbos biome, where alien invasive plants are one of the major threats to biodiversity, alien invasive species are also a major threat to biodiversity in dune landscapes of the Cape. In mountain fynbos, pine trees are the major threat, but in these coastal lowlands, and specifically in dunes, Acacia species from Australia are the major problem. In our dune landscapes, the most prominent invader is Acacia cyclops, rooikrans, but we also have major issues with Acacia saligna, the Port Jackson willow. The major issue with alien invasive plants is obviously that they are able to outcompete any of the indigenous species that we have in these systems. But other than that, another very, very serious issue is the issue of fires interacting with these alien invasive species. So, for example, what we find here, previously this was a patch of that was invaded by Acacia cyclops, and recently a fire burnt through here, and as we can see, Acacia cyclops is recruiting quite happily from seed, but surrounding it is just a barren sandy patch. Even resprouting species are struggling in these invaded patches.
I'm not sure if you can see Adrian over there, but he's standing in that patch of Acacia cyclops that we were just visiting. So I've just shifted slightly away from that invasion area to show you what the resprouting looks like from a range of other species. So this is Euclidea Rasamosa. There's some Circia in here, and the odd olea as well that's popping through. So you can see that the resprouting after the fire in this patch is orders of magnitude higher than what is happening under that area that was invaded by Acacia cyclops. So Acacia cyclops has an effect both on the reseeding and the resprouting communities of the dune fynbos thicket mosaic.
Thank you for joining us for our virtual field trip in Nelson Mandela University Reserve.
We hope you enjoyed it and learned a few new things about this fascinating landscape.